the intermediate value theorem holds or not. So I can see that from here, and you can use your calculator, and or you can install a MATLAB. Okay, so I'm going to check that z of 1.5 times z of 3. If it is a negative number, I will keep this interval. Okay, otherwise I will discard this interval. So let's see. Now the answer is a negative number. Okay, so you will, it is a negative number, so you will say keep it. Okay, now go to the next step. What is the next step? The next step says that you will now, your main interval is now this interval 1.5 till 3, and what are you going to do? You will find the midpoint of this interval. Okay, so what is the midpoint of 1.5 and 3? So 1.5 plus 3 divided by 2, 2.25. Okay, so we have here 2.25. Okay, let me this is my new picture. Okay, now I will apply the intermediate value theorem on this subinterval, then on this subinterval. Okay, so let us go to the next part. I want to apply the intermediate value theorem. This means that I want to check the product of z of 1.5 and z of 2.25. Okay, so let us check it. Z of 1.5 dot steric z of 2.25 dot steric is the MATLAB syntax. You can see it is a negative number. Okay, so we have here less than 0. Intermediate value theorem holds. Keep this interval. Okay, now you will have here z of 2.25, z of 3. Let us check if it is a positive number, we will discard it. 2.25 and 3. So it is a positive number. So according to the intermediate value theorem, discard it. Okay, so now my new subinterval, students, now my new subinterval is select 1.5, 2.25. Okay, apply the bisection method again. Okay, so okay, so we have got 1.5 and 2.25 as the new candidate for the bisection method interval. Okay, so I'm going to write it here. Now my new interval is 1.5 2.25. Okay, so what is the midpoint? Let us go to the midpoint. 1.5 plus 2.25, 2. So we have 1.875. Okay, 1.875. Okay, now let us check or apply the intermediate value theorem here, and then let us apply the intermediate value theorem here. How you will say that actually these two lines must coincide because it is a closed interval. Okay, so and the length of these intervals should be same. So let me just put it in the middle. Okay, and this part that looks equal, and then this part. Okay, I'm going to apply the intermediate value theorem. Okay, so I will say that here I have got 1.5. Okay, so now I'm going to check z of 1.5 times z of 1.875. If it is less than 0 or greater than 0, let us check it. So z of 1.875 and z of 1.5. Product is a positive number, so you will say that it is greater than 0. So discard it as intermediate value theorem fails. Right? Next we have here z of 1.875, z of 2.25. Let me check it. Bring your calculators, okay, and do the calculations with me. Z of 1.875 dot steric, z of 2.25. So negative number. Excellent. So we will keep this interval and repeat the algo. Okay, and what does the algo says? It says that you will find the midpoint of 1.875, 2.25, and then you will make two subintervals, and then you will check the intermediate value theorem. Okay, and you will repeat the process. Now the homework is, students, there are two homeworks, right? Number one is that you will apply it 3 more times. Okay, number one. And homework number two, read algorithm. So you can read the algorithm from the book. Okay, here is the book and page number 124. The algorithm is given here. Okay, otherwise you can read the algorithm and write it on your notebook from this slide. The function must be continuous. The functional values at the boundaries must have opposite sign. That is, their product is less than 0. Divide the interval and again apply the intermediate value theorem. Okay, this was the first lecture. Okay, with the passage of time, you will see that you will develop interest in numerical computing, numerical computations, and try to install MATLAB on your computers. Try to download the book. I have shared it with CR. Good luck, and I hope to see you soon. Okay, Allah Hafiz. Bye-bye.